welcome back to my channel, The Machining Maestro. So today I'm going to explain you the center drilling operation to be done in a CNC lathe machine by using the Siemens Sinumerik controller. So from this orthogonal drawings, you can get the idea that we have done the center drilling operation here, and this is the structure of your center drill where it has gone up to 8 depth uh, into the cylinder face, and here is the diameter of your cylinder, and 50 is the length of your cylinder. And the tool what I have used over here, this is the tool which is A4 into 10 size. Okay, so A4 is the pilot hole diameter. This diameter is your 4 and 10 is the shank diameter, and this starting angle is always like 118 or 90 degree, but this angle is your 60 degree in case of A4. Okay, so let's go and create the program for the center drilling or centering operation also you can say. So in my next clip I will show you how to create the program. We are going to create the program for center drilling. So for that you need to click on this program manager, and out of these three directory you choose part programs directory. And when you click on this plus icon, you see the various programs are available what I have taught you in my last in my past videos. So here we want to create a new program for center drilling. So for that you click on new button, and here you define the program name. So I'm defining the program name as centering. So then you click on OK. So this program window got appeared over here. So now the first thing as always we do that we define our workpiece over here. So for that you click on this various icon, then you click on this blank, then you choose your blank type. When you go here and click on select, you see that various options are available here, but our workpiece is actually a cylinder, that's why you click on this cylinder. Okay, then xa is the diameter of your workpiece. So in our orthogonal drawing view we have seen the diameter of your workpiece is 40, so that's why I'm keeping 40. Then za is the starting length of your workpiece. So starting length of your workpiece is always 0. Zi is the total length of your workpiece, which is minus 50. If if uh, if any other value was over there, then you could have written minus 50 over there. So suppose your length is minus 60, you just write minus 60. Okay, so since our length is minus 50, so I'm writing minus 50. Okay, minus 50, then input. Then again zb is the length you are keeping outside of your jaw for the machining. So since we are doing the drilling operation, so this value is really not necessary, but again we have to give some value, so that's why I'm giving minus 30. So imagine your total length is minus 50, where your your chalk is holding around minus 20. However, minus 30 is outside of the jaw for the machining. So ZB is the length between the face to the jaw face. Okay. So then this part is completed. Then you click on this accept button. So your workpiece has been created. Now you click on input. So we need to define some of the basic G codes over here. First is Z90, it is the activation of absolute mode. Then Z71, the activation of metric or mode. Then Z95, it is the feed in per revolution. Then after that press input. Then we need to call our tool, or we need to define our tool over here. So for that you click on edit, then you click on the select tool. So here you check that there is no drilling tool has been defined earlier. So for that we need to create a create a tool over here. So for that you click on this tool list, and based on your location capacity of your turret, you create your tool in the available or empty locations. Okay, so I'm choosing the position number 9. Suppose I'm choosing the position number 9. You click here, then click on new tool, then you click on this drill button. Then out of the available categories of drill, you see that there is a center drill option in 220 type. So you select this, then your position will always like from right to left. So this is the position, then you click on OK. So you see the center drill has been created. So after that press input, and the sister tool and the cutting edge number, these are like automatically getting stored as 1 and 1 respectively. So regarding that we will discuss in our coming videos, uh, because that's a long story. So again, when you go for the length x and length z, these two are like the diametrical sorry radially difference between your machine home position to the workpiece home position, and length z is the uh, distance between the longitudinal distance between the workpiece face to the machine home position. Okay, so these two are something we generally get after the reference of tool. But in this case, since we are not doing any practical, we are just doing for practice or example. So I need to assume some value over here, like I did some assumptions for the special learner tool in my past videos. Similarly, I need to assume. So use meaning in an assumption I'm putting minus 250, considering the radial distance differences between the machine home to the workpiece home is minus 250. So again I'm considering minus 300 is the longitudinal difference between the machine home to the workpiece home position. Again it is asking the diameter is nothing but is 4 mm here. This 4 mm is the pilot drill size. Okay, so shank size you don't need to put the shank size. We should put the pilot drill size, because based on that we are calculating our rpms and putting the rpm values in the program. So again the tip angle is the like in for softer material it is 90, for harder material hardened materials it is like 1 on 80. So that is completely optional, you can put any value you want, either 1 on 8 or 90. So it is already 90, but I'm keeping 1 on 8 because in my drill case my center drill case the tip angle is 1 on 8. So you put 1 on 8, then press on input, then you click on this to program button. You see the tool has been created and automatically got appeared in the program. So now you click on input, then you define the spindle rotation. So I'm defining the spindle rotation counterclockwise, which is m4 s 1500, meaning spindle speed I'm giving 1500 rpm. Okay, so then you click input again, then you take your tool towards the workpiece. So before approaching to the drilling operation, we need to take our tool to the safety position. So for that you need to write z0 z2.0. Then again it has done in longitudinally, then radially we have to travel, we have to take our tool to the workpiece, near to the workpiece. So for that you write z0 x 0.0. Why x 0.0? Because the drilling operation always happens at the center position of your workpiece. So that's why we are keeping x as 0 0.0, because at your center position of your workpiece your diameter is 0, that's why we're keeping x 0. Okay, so again after that you press input, then you have to define the coolant on option, so that is M7. So we are turning on coolant over here. Then again after that press input, then you have to give the feed rate here. So for giving the feed rate you write down f 0.02, which is like 0.02 mm per revolution. Okay, so you just define the feed rate over here, because in your program parameter there is no such options available for the feed rate. So feed rate you have to define separately after the coolant on or before the coolant on, that is okay. So after that press input again, then you need to define the cycle here. So for that you click on drilling, then out of these options you click on centering, then you select the plane. Those Z71 is your XY plane and Z18 is your ZX plane and Z19 is your YZ plane. So we are doing the drilling operation in Z17 plane, so you see the Z17 plane, so you select Z17. Then RP is nothing but the retraction plane. Retraction plane you just keep 1 mm, no problem. Safety height, the safety distance or safety height or safety distance you can say. So after each drilling depth, meaning after the completion of drilling, it will reach to a safety position of 1 mm. So you just keep both RP and safety distance as 1 and 1 respectively. So again it is asking for the machining positions. So if you want to look for the options, there are two options are available, which is this multi option and single option. So multi option you cannot do in a lathe machine, because for that you have to use the turn mill machine, where you can do the drilling at different positions of your workpiece. But in a lathe machine only, uh, you can do the drilling at the center. So you have to select single position here. So you select this one, then Z0 is the starting length of your workpiece. And when you come here, centering in relation to depth. So in our case the drilling depth is 8 mm. From the drawing you have seen the depth of the drilling is around 8 mm. So the 8 mm is actually, from this drawing you can see the 8 mm is actually calculated from the tip to the workpiece face. So here after clicking on the select, you see there are two options. One is diameter, one is tip. So when you click on tip, so your dimensions of depth will be calculated from the tip only. So since in our drawing it was calculated from tip, so you click on tip and select tip. Then you go to Z1 is the total depth. So total depth is our minus 8. Why minus 8? Because 8 mm has already defined in the orthogonal drawing, and we are going in negative direction, that's why it's minus. And here you always choose absolute, because we are considering everything in a absolute mode. Then dt is your dwell time. Dwell time is not required if you are keeping dwell time, some meaning if you are keeping 2, it means it is meaning after the drilling operation it is meaning it will remain for 2 seconds inside the hole, then it will retract and your program will be finished. So if you are keeping the dwell time, then the drill bit will spend that seconds of time in your inside your workpiece. So in our case this is not required, so I'm giving 0. Okay, so 0, then press input, then click on accept. So your cycle has been defined. Then after that press input, then you take out your tool to the safety position Z0 Z2.0. Then again, you turn off your spindle, which is M5, you turn off your coolant, which is M5 M9. Then you take your tool to the homing position. For that you have to write the homing program, which is T0 D0, then Z0 X0 Z0 Z0. These three line will do the homing of your X and homing of your tool in X and Z. Okay, so then after that you have to complete your program by writing M30. M30 is the program and command. Okay, so that's all your related to the programming. So after that we will check the simulation. One more thing, that suppose your tool is not in the homing position, it is in a in different random places. So in that case you just need to write the homing program after this workpiece creation. So even though you are not writing, that is also okay, but for safety reasons you should write over there. So for that you go to edit. Now you click on mark, you start marking from here. Sorry, you click marking from here and copy that. Then you go here, then press input, and here you paste. So so first you do the homing, then you write down the necessary programs, necessary G codes and codes. Even though you are not writing the homing program, that is also okay, it will do the required operation. Okay, so now we'll check the simulation. So go to simulation. So I'm making 3D view. So it has come and done the drilling over here. So from further view I can show you. So from this half cut view you can see it has done the drilling up to minus 8 mm. Okay, so that's all about your simulation. It was very fast, so I will reduce the speed I need to reduce. So to reduce the speed, you just need to click on this program control and this maximum over speed 100% speed, and you can increase the speed and reduce the speed. So I'm just reducing the speed, and again I will start the simulation. For that you just need to see it has done the drilling. Again it was very fast, so just reduce the speed. Again you have to start. Okay, so you have seen that it has done the centering up to minus 8 mm. So that's all about your center drilling operation. In my next video I will show you the peg drilling cycle. Peg drilling cycle is nothing but like in center drilling, actually you are taking depth at a time, like minus 8 mm you are taking in a single depth. You are performing the drilling in a single step only. You are not doing the drilling in you're going something, coming back, then again going something. So it means you are not doing anything incrementally over here. So but in peg drilling we will do the drilling operation incremental, in a incremental depth of cut. So there I will explain you how to define the parameters for the peg drilling. So that's all about today's center drilling program. Thanks for watching.